Hello, and welcome back to Educator.com and our series on AP Computer Science. Today's lesson is on searching. We'll first talk about searching and some general considerations about searching and how we implement searching. Then we'll look at two specific methods of searching. One is known as sequential search and one is known as binary search. We'll talk about the pros and cons of each, and then finally we'll conclude with some specific trade-offs and considerations to take into account when you're considering implementing a search algorithm. Searching is simply looking for a particular value in a collection, like an array. And there are multiple search algorithms, and the choice of which search algorithm to use depends largely on whether the items in your array are sorted. If the items are not sorted, then it's potentially necessary to examine every value in the array to determine whether a particular value is present in the array or not. If the items are not sorted, the value you're looking for could potentially be in any of the n values in an array of n items. So you may need to examine every item. Once you have found an item, you can exit the search algorithm and return back to the calling program and indicate that the value is found. But if the value is not found, if the value is not in the array, you need to examine every item in the array to convince yourself that it is not anywhere in the array. And potentially the item could be in the very last position in the array. So if it's not sorted, the performance is definitely going to be a factor. Now, if the items are sorted, then searching can be accomplished much more efficiently via an algorithm that takes advantage of the fact that the items are already sorted. The first type of search that we'll talk about in this lesson is sequential search. Sequential search can be performed on any array, whether the array is sorted or not. So if the array is not sorted, you must use a sequential search. If you're not sure if the array is going to be sorted, then you should use a sequential search. Sequential search is an order n algorithm. That means that if you have n items in your array, it could potentially take n operations to determine if the value you're looking for is in the array or not. Because if it's not there, you definitely need to compare every item in the array looking for it. And even if it is there, it may be in the very last position. So that's why it's order n algorithm. For very large arrays, performance may be slow. Sequential search uses an iterative algorithm. Typically, you're going to use either a for loop or a while loop to implement sequential search. If the desired value is found, you can exit the loop immediately and return the value. If the loop reaches the end of the array without finding the desired value, then you're going to return some other value that is not a value that may be in the array to indicate that the desired value was not found. So for example, if the array contains positive integers, you may decide to return a value of -1 to indicate that the value was not found. If the array contains strings, then you may have some special purpose string that is used only to indicate that the string you're looking for was not found. So here's the sequential search algorithm as implemented with a for loop. We have sequential search, and we're going to accept two parameters. We're going to accept an array A of integers. We can search for any particular type of data, but in these examples we'll search for integers. And we're going to accept a search value. That is the value that we're looking for in this array of integers. So clearly this value, this type, int, should match the type of the data that you're searching. I have a simple for loop here. I go from 0 to less than the length of the array, and I increment my loop counter each time. And it's just a simple if statement. If the array item in position I is equal to the search value, then I'm going to return the search value. And notice I'm returning from within the for loop. So that exits the for loop and exits the sequential search method. As soon as I've found a value, I don't need to keep looking for it in the rest of the array. So my performance isn't necessarily going to be n comparisons every time. If the value I'm looking for is very close to the beginning of the array, then it will find that and return it considerably faster than running the entire loop of n comparisons. If I've reached the end of the for loop and I haven't returned yet, then I'm going to return -1. And my convention for my program will be that if I get -1 back, that means that the value I was looking for is not found in the array. So let's take a look at how we would implement this in a real Java program. Here is the same sequential search logic using a for loop from 0 to less than the length of the array, and it's exactly the code that we saw in the previous slide. If I find the search value in position I return it. If I get to the end of the loop and I haven't found it yet, then I'm going to return -1. I have my main method down here that is going to call the sequential search method here. I have an array of ints called unsorted array, and as you can see, there are just some integers in random order. It's not sorted. And so I'm going to have a for loop here going from 0 to less than 15. And for each iteration of the for loop, I'm going to call sequential search with the same unsorted array, looking for whatever the value is of the loop counter. So the first time through the loop, I'm going to see if the value 0 is found in the unsorted array. The next time through, I'll look for 1, and then 2, and so on. And each time, if the sequential search method returns me a value equal to the value that I'm looking for, that indicates that the value was found. And I'm going to print this message that that value is found in the array. Otherwise, if the return value doesn't match what I'm looking for, then I'm going to print this message that the value is not found in the array. So let's run this, and I'll expand this. And here we can see the values in the array and the results of doing this sequential search. It tells me that 0 is not found in the array, and that's true. 0 is not one of the elements in my unsorted array. 1 is found in the array. That was right here. 2 is not found. 3, 4, and 5 are found in the array, and so on. So it did work exactly as I wanted it to.